Alright, welcome back guys. We're going to start section 2.1, and as you can see this section is on graphing equations. Later we're going to call these functions. Okay, basically what we have going on is we have a relationship between two variables, x and y. Okay, and typically you'll see relations like this written as what are called ordered pairs. Let me zoom in a little bit. Okay, so for example, you might have a value of x, and then over here you'll have a corresponding value of y, and this is what we refer to as an ordered pair. Okay, it's a pair because typically you'll have two numbers, and the order matters. Whatever comes first is the value for x, and the number that comes second will be the corresponding value for y. Now, we're going to start off working with linear equations. Okay, we're going to be graphing these. And then we're going to transition down here in probably another video to graphing nonlinear equations. Okay, so a linear equation is just an equation that when you graph that relationship between x and y, it is linear. In other words, it forms a line. Okay, and what that means, guys, is that if for every fixed increase in the value of x, y will change by the same exact amount. Okay, so for example, you might increase x by a value of 1, and then the value of y might increase by a value of 2. And so when you increase x again by 1, that value of y will increase by 2. Okay, and so that relationship stays fixed. It never changes, and that's what causes these relationships to be linear. Now, to graph these, we're going to do it by plotting points. Okay, and I like to refer to this as an XY chart. And so typically x is what we call our independent variable, and y is referred to as the dependent variable. And what that means is that the value of y will depend on the value of x. Okay, so when you have a relationship, a relation or equation like this one right here, as you substitute different values of x, then y will depend on those values of x. Okay, and so typically what we do, we choose values of x, and we plug those into the equation, and we solve it for y. If it's not already solved for y, or in other words, we evaluate it and see what that corresponding value of y is. Okay, all right. So let's go ahead and get started, and we're gonna plot these ordered pairs. Now, we need at least 2. When we're graphing linear equations, we need at least 2, because if you remember when you were small and you were working with a ruler drawing straight lines, you need 2 points. Okay, you want to draw a straight line, you just need to line that ruler up with 2 fixed points and then draw your line. Okay, so similarly, when we're graphing these linear equations, we're just going to need 2 ordered pairs. That's it. Now, we could come up with many. We could come up with as many ordered pairs as we want, but all of those ordered pairs are going to fall on that same exact line. Okay, so that's why we're only going to use 2. All right, so let's try this one. Example 1 here. It says, graph the following equation by plotting points. All right, so you can see I've got my XY chart here. And so I'm going to choose my values for x. And typically, guys, 0 is always a good value to choose for x. And the reason is because if I rewrite my equation and I substitute 0 in for x, then when you're doing calculations with 0, especially with multiplication, they're a lot easier. Okay, anything multiplied by 0 is always going to be 0. And so 2 times 0 will be 0. So we could write y is equal to 0 minus 1. And then 0 minus 1 is negative 1. So that corresponding value of y is -1. And so I'll put that here in my chart. So this just means that whenever x has a value of 0, y will have a corresponding value of -1. And that gives us this ordered pair, 0, -1. Now I'm going to pick another value for x. And, you know, we could let x be any number we want, but I want to choose a value of x such that I get a nice value of y. Okay? And furthermore, that it lies on this Cartesian coordinate system. So I don't want to choose a value of x that I get this such that I get some huge value of y. Okay. So I don't know, maybe for my next value of x, I'm just going to let x be 2. And so I'll do the same thing. I'll rewrite my equation and I'll substitute a value of 2 in for x. And I'll evaluate this. So remember, you've got to do your multiplication before your subtraction. So 2 times 2 is 4. And this will give us 4 minus 1, which is 3. Okay. So when x is 2, y is going to be 3. Now I've got two ordered pairs. Now all I need to do is plot those on my Cartesian coordinate plane. So 0, -1, when you're plotting these guys, what I like to do is start on the x-axis first and let that first coordinate value tell you where to move. So if it's negative, you can go to the left. If it's positive, you go to the right. And then whatever that corresponding y-coordinate is, you'll either go up or down. Okay, well, since the x is 0, I'm not going left or right. And then since the y is -1, I do need to go down 1. And this is where I'm going to plot my point. So that's my first point. Now I need to plot this second one. It's 2, 3, so I'll start right here at the origin. I'm going to move to the right 2, and then up 3. That's going to put me right here. Okay. Now if you were doing this by hand, you would then draw a straight line, maybe with a ruler, through those 2 points, and you would put arrows on the end, just showing that this relationship holds forever, okay, for all values of x. In other words, this line goes on in both directions. Now what I want to do real quick is show you how you can use your calculator to assist you in graphing. And turn it on. Okay. All right, now notice this equation starts off with y equals. So whenever your equation is in that form, you can graph it using the calculator. When it's in this form, guys, we say that y is a function of x. In other words, y is determined by x. Okay? So what you'll do is you'll go to this y equals key right here. You'll click it. And you'll type in your function or equation. Okay? The y equals part's already in here for you. You can see that I had a previous function in there. So now all I'm going to type in is 2x minus 1. So I hit 2. Your x key is going to be right here, or your variable key, and then you're going to say minus 1. Note, there's a difference between the minus, or the subtraction, and the negative. Okay, so we want minus and then 1. Now, you can just hit this graph key and it'll graph that line for you. Okay. Hold on just a minute. There we go. This is the same 20 by 20 that I have here in the notes. But just looking at this, it would be hard to know exactly where to put those 2 points, okay, or what 2 points to use. So fortunately, the calculator will actually create an XY table the way we did, except it'll do it for an infinite number of values of x. And so to access that, it's right above the graph key. You have to hit the second key, and then the graph key, and it'll take you to the table. you can see it just lists a bunch of values of x. You can see I'm way down here, so I'm going to scroll up, and we'll be able to find these two ordered pairs that we found. See? 0, negative 1. And then if we go down, here's 2, 3. Okay? So you could use your calculator to assist you. 4, 7 is a point on this line. 4, 7, it's right here. Okay? So anyway, I'll go ahead and get out of that. All right. Now, in the homework, and I'll demonstrate this here in a minute, you'll actually have to manually plot 2 points, okay, similar to how I did on paper here. All right, so let's try another one. Example 2. All right, so example 2 is similar in that it's solved for y. It says y equals, and it's similar to the last one, something times x plus or minus some number, okay? The only difference here is that there's a fraction. We're multiplying x by a negative fraction, okay? But guys, we need not let that deter us. What we can do when we go to start picking our values of x, we can go ahead and start with 0. And that's what I'm going to do. I'm going to let x be 0. And so I would have y is equal to negative 5/3 times 0 minus 2. This is another reason why 0 is a good value, because 0 times any other number is always 0. Doesn't matter if that other number is a fraction. So I end up with 0 minus 2, which is negative 2. Okay. All right. Now I need to pick another value of x. Now here, because I'm going to be multiplying my value of x by this fraction, you've got to be a bit careful, because if I choose a value of 1 or 2, or negative 1 or negative 2 even, then I'm going to get stuck with a fraction for my value of y. Okay? And those are going to be difficult to plot. And so typically what I can do is I can choose a multiple of 3 right here. Since this denominator is 3, I could choose a number for x like 3, 6, 9, 12, or I could go in the negative direction. Negative 3, negative 6, negative 9, etc. Okay? I'm just going to go with 3. Okay, so I'll do the same thing. I'll have y is equal to negative 5/3 times 3 minus 2. The reason you want to choose a multiple, guys, is because what's happening here is this 3 is in the denominator, and this 3 is essentially in the numerator. So this is like 3 divided by 3, which is 1. And sometimes people will say, well, these divide out, and that just leaves us with negative 5. Okay, so we're left with negative 5, and then we still have the minus 2. And negative 5, take away 2, gives you a bigger negative, gives you negative 7. And so that will be our second ordered pair. And I want to show you real quick that you can do fraction arithmetic in your calculator as well. Okay, I've already got it on. So there's a couple ways you can do it. You can type in negative 5 divided by 3, and then multiply it by your number, which is 3 in this case. Hit enter, and it'll give you negative 5. The other way is you can hit alpha and then the y equals key. And that'll bring up this menu, and you can select number 1, and it'll give you a template for a fraction. And inside this template, you can type in negative 5 over 3, and then multiply that by 3, hit enter, and you'll get negative 5. The nice thing about using the template, guys, is if the result is ever a fraction, the first method would convert it to a decimal, and then you'd have to turn it back into a fraction. But this method, when you use the template, will keep it, will give you the answer as a fraction. Okay, so in any case. All right, well, we've got our two ordered pairs here. I'm going to go ahead and plot those, 0, -2. It's going to be right here on the y-axis. And then 3, -7. So I'm going to go to the right, 3, and we'll go down 7, and it's going to put me right there. And I'm going to sketch a line through those 2 points. Not a very good line, but a line nonetheless. Okay. All right, let's just kind of verify this using the calculator. Use some more practice. So I'll go back to y equals, and I'll type in -5 divided by 3. And I'll hit my X key, and then say -2. I'm going to go ahead and go to the table, so I'll hit second graph. And guys, see, what did I tell you? If I had chosen 1 or 2, it's giving me the values of y as decimals, but these are really fractions, okay? But you can see here's 0, -2, and here's 3, -7. And look down here, if we had used 6, we would have got a nice number. It's just that this number would have been off of our viewing window, okay, -12. And then you can hit the graph key if you want, and it should look similar to what you get. All right. Okay, well, we're going to do, I think, one more for this part 1 video. All right. So example 3 we're going to tackle the same way. It is a linear equation. Guys, the reason I know that it's linear is because there's one x and there's one y. The y is not squared, or it doesn't have an exponent. The x doesn't have an exponent. Okay. But what's different about this one is that it's not written as y equals something. Okay. And that's what we actually need to do first. You can see both the x and the y term are over here on the same side of the equation. So I want to try to solve it for y, essentially. And I'm going to come over here and do that. I'm going to recopy my equation. 6x minus 3y is equal to 3. And so I'm going to try to keep my y on the left-hand side. Okay. When you do this, guys, when you're solving a linear equation for y, you're putting it in what's called slope-intercept form, or this form right here, in other words, where m and b are just numbers. Okay. And so the way I move or I eliminate this 6x term is by subtracting it, because it's a positive. So I'll subtract 6x from both sides of my equation. Because on the left-hand side, 6x minus 6x is 0, so I have nothing left right there. So you can just cross those out. And so all that leaves me with here on the left-hand side is the -3y. -3y equals. Now, on the right-hand side, I need to try to subtract 6x, but I can't subtract 6x from 3. These are what we refer to as unlike terms. One of them has an x, and we call that a variable term, and the other one doesn't. This one's called a constant term. So you can't actually subtract 6x from 3, because we don't know the value of x. So what we do is we just rewrite them. And if I want to keep it in this form right here, I'm going to put my -6x term first, and I'm going to put my +3 second. I put +3 because it's a positive right here, okay? All right, now, I got one last step. I need to divide both sides of this equation by this -3. I'm dividing because I'm doing the opposite. The y is getting multiplied by -3. So I'm going to divide both sides by -3. Now when you divide the right-hand side by -3, you've got two terms. So you put the -3 under both of those terms. So on the left-hand side, -3 divided by -3 is 1. So we're left with 1y, which we just express as y. There's no need to put the 1 in front of it. It's understood to be there. Equals, and then over here, guys, this will actually divide evenly. -6 divided by -3 is an even 2. So this will give us 2x, and then 3 divided by -3 is a -1, okay? All right, so now I have it solved for y, so now I can go about picking my values of x. But you know what? I'm just going to use my calculator this time, and you'll see why here in a minute. So I'm going to retype this in. See, I can't use my calculator unless it's expressly solved for x. Now I can type in 2x and then -1. Now I'll go to my table. I'm just going to look for a couple ordered pairs. 0, -1. I'll go ahead and take that one. And right here I'm just going to say from table and the calculator. All right, now I need to get another ordered pair. How about we go with 3, 5? Okay. 3, 5. I'll plot these two, 0, -1. You're just going to go down 1. And then 3, 5, you're going to go to the, hold on just a second, guys. All right, my computer froze just for a second. Yeah, so as I was saying, I'm going to go to the right 3 and then up 5. Okay. And I'll plot that second ordered pair. I'll connect these 2 points with a straight line, and I'm done. Okay. Now, I don't know if you noticed or not, but once we solved this guy for y, it became the first example. So really, we redid the first example. Okay. But you'll notice I used a different second ordered pair, yet we got the same line. Okay. All right, so now the last thing I want to do is I want to go into the homework. I want to show you how to plot these, graph these. I'm using the software. Okay, 2.1. Oh, this is the one that you missed on the demonstration video. Let me not use this one. This is just like the example we just did. Let's see. We haven't got to that yet. So really there's just question 1. All right, so this one, guys, I'm just going to kind of do this one in my head, but you'll make a chart or use your, actually, why don't we just use the calculator? So it's already solved for y, so I don't need to do anything there. But I need to type in 3/2 x plus 1. So 3 over 2 x plus 1. I'll go to the table. All right, so now you can see if I had chosen certain values of x, I'd be getting fractions for those values of y. All right, so we can use any 2 ordered pairs, but you've got to click here to enlarge the graph, and you've got to pick the type of equation it is. We are graphing linear functions or equations right now, so you're going to use the line tool. Now in the part 2 video, you'll be using some of these other tools, okay? Because we'll be graphing nonlinear equations. So I'll graph this one, and you're going to need to plot 2 points. So I'm going to look at my calculator, 0, 1. So guys, well, you can't really see my cursor for some reason, but if you look up here in the right hand corner, it'll always show you the coordinates of where your point is. Okay, so 0, 1. I'll click right there. Okay. Now with that 1 point, I've basically got my line. I just need to fix it in the correct orientation, and that's going to depend on where I put my second point. Okay. Also notice too here, guys, this axis is subdivided into increments of 2. So be careful with that. Anyway, let me go back to my calculator. Why don't we get, I don't know, maybe 4, 7. Okay. So when you graph this, start at the origin, but don't click. You only click when you've got your cursor where you want that point to be. So I'll start right here, but I'm not going to click. I'm going to go to the right 4, right there, and we'll go up 7. You got to be careful doing this. So right there. And again, look at the top right. Make sure those coordinates match what you want. And so now I'm going to click. And that fixes my line. Okay? And so once you've done that, you're going to save it. And you're going to check it. Alright, so it may take you a little bit of practice to get that down, but just be patient. Okay? Alright. That's not what I wanted. Okay, so that was the first part on graphing linear equations, and you actually only have 2 homework problems. Now, in the next video, we're going to go over graphing nonlinear equations, and we're going to see different types of equations as well, okay, in the part 2 video. Alright, so I'm going to go for now.